Okay, so we're all pretty used to AI that can chat, right? But what if AI could actually do things? Today on The Explainer, we're diving into the next massive step in AI's evolution, building systems that can sense the world, think about it, and then take real action. Let's get into it.
And yeah, that's really the big question here, isn't it? We know for a fact that AI has mastered language, but can it really jump from just understanding our words to taking meaningful action? In the real, messy, physical or digital world. Can it actually perceive, process, and then do something? This slide really gets right to the heart of it. Over on the left, you've got the AI we all know and use, large language models, or LLMs. They are fantastic conversationalists, but they're fundamentally reactive. You ask a question, they give an answer. But on the right, that's where things get interesting. We've got autonomous agents. These things don't wait for you. They are constantly observing, making decisions, and acting on their own to get things done. We're moving beyond simple conversation and into true collaboration.
All right, so let's dig into that shift, from just language to full-on autonomous operation. Why isn't a brilliant chatbot enough when you're trying to automate the world around us?
Let's make this super real for a second. Picture a factory robot. It's not enough for it to have just read the instruction manual. No way. It needs to be able to see that a conveyor belt is slowing down, feel that a machine is starting to overheat, and then decide what to do about it in a fraction of a second. Should it pause the line? Kick on a cooling system? Ping a human for help? That's the kind of split-second, real-world intelligence we're talking about.
So how do we actually build these AIs that can act? Well, the key is to move past just using language models and start using a whole new class of tools. So let's talk about something called the Agent Development Kit. An ADK is basically a foundational toolkit. It gives developers all the pre-built parts they need to build an AI that can perceive its environment, through sensors and data feeds, then reason over all that information, and finally execute actual tasks.
And at the absolute core of every one of these agents is this simple but incredibly powerful loop. First, it senses the world around it, pulling in all kinds of data from sensors or software APIs. Then, it thinks. It analyzes all that data to figure out the best thing to do. And finally, it acts, carrying out its decision. Sense, think, act. It's the fundamental pattern for autonomy. It's the secret sauce.
This is just the perfect analogy. If a large language model gives AI its voice, then an agent development kit gives it the hands to actually interact with the world, plus the brain to decide how and when to do it. It's a huge shift from AI being just a commentator to AI being a participant.
Okay, I know this might still feel a little abstract, so let's get super practical. We're going to walk through how you'd actually build a simple but really useful agent for a smart office. Building a basic agent isn't as complicated as you might think. It really follows this logical 6-step roadmap. You start with the goal, figure out its senses and abilities, pick your tools, test it like crazy, and most importantly, you build in safety right from the very beginning.
Let's start building our smart office agent together. Step 1, what's our goal? Well, let's say we want it to keep the office comfortable and efficient by automatically managing the temperature and the lighting. Simple enough. Next, we have to give it senses. How's it going to know what's going on? We'll feed it data from temperature, light, and motion sensors, and maybe even let it check the weather forecast online. And finally, we have to give it the ability to act. What can it actually do? Well, it can adjust the thermostat, dim the lights, or maybe send a Slack message to the office manager to let them know what's happening.
Okay, on to step 4, assembling the technology. For this, we'll use Python for the agent's logic. That's the brain. We'll use an IoT hub to act as the senses, collecting all that data from our sensors. And then we'll use REST APIs as the limbs, which lets the agent actually control things like the thermostat and the lights.
Now for the last 2 steps, and honestly, these are probably the most important ones. First, we test. And I mean, we throw everything we can at it. A sudden heat wave, an empty office on a holiday, a team pulling an all-nighter. We need to see how it responds and then tweak its logic. And finally, we build in safety from day one. We add a manual override so a human can always take control. We log every single action it takes, and we make sure we have the consent of the people working in the office. And just like that, you've got a smart, safe, and effective AI agent.
That last bit about safety is so fundamental that it really deserves its own moment. See, when you build something that can act on its own, responsibility isn't just an add-on. It has to be baked into its core design.
This whole idea of responsibility is really built on 3 core principles.
And these aren't just, abstract ideas. They are practical, nuts and bolts engineering requirements for any autonomous system that people are actually going to trust and rely on.
First up, fairness, and this is a big one. An agent is only as objective as the data it learns from. If that data is biased, its actions will be too. Imagine our smart office agent sees historical data that one department always works late. It might decide to keep the lights and heat on for them while plunging the rest of the office into a cold, dark cave. That's not a good outcome, and it's exactly the kind of thing you have to design against from the start.
Second is safety. Plain and simple, what's the backup plan? You gotta have a backup plan. A safe agent always has one. That could be something like an undo button for a recent change, an automatic alert that goes to a human supervisor, or even a rule that requires human approval before taking a really critical action. There must always be a kill switch and a clear line of control.
And third, trust. Because let's be honest, people will not use systems they can't understand or rely on. Trust is built through transparency. This means keeping a clear, auditable log of every single action the agent takes, and, this is key, being able to explain why it made a decision in simple, plain language.
With these principles as a foundation, the potential for autonomous agents is, well, it's just staggering. So let's look ahead a little bit at what this autonomous future is already starting to look like.
And look, this is not some far-off sci-fi future. This is happening right now. AI agents are already starting to manage traffic flow and power grids in our cities. They're in hospitals helping doctors spot diseases earlier. They're on farms figuring out the best way to water our crops. They're in our financial systems protecting us from fraud in real time. And this is really just the beginning.
So, what's the big takeaway here? It's this. The next great leap in AI isn't just about building bigger and bigger chatbots. It's about building smarter, interconnected systems that can act as our partners in the real world. Systems that are designed from the ground up to sense, think, and act, and to do it all responsibly.
We started this by asking if AI could go from just chatting to actually acting. And the answer is a definite yes, and the tools to do it are here right now. So the final question really isn't if this is going to happen, but who's going to build it? Are you ready?